Imagine a world where everything is reversed. Up is down, left is right, and matter, yes, matter is antimatter. It sounds like science fiction, doesn't it? But antimatter is real. It is the bizarre twin of ordinary matter, and it holds secrets to the universe's greatest mysteries. Every particle in your body, every atom in the chair you are sitting on, has an antimatter counterpart. An anti-electron, called a positron, has the same mass as an electron, but carries a positive charge. Antiprotons are like protons, just with a negative charge. It is a mirror image, a cosmic doppelganger. But here's the catch: antimatter is incredibly rare. Why? It's a question that keeps physicists awake at night. In the grand recipe book of the universe, antimatter seems to be a missing ingredient. When the universe was born in the Big Bang, we believe equal amounts of matter and antimatter were created. But look around. Our world is made of matter. So where did all the antimatter go? It's one of the biggest unsolved mysteries in physics. Some theories suggest that maybe, just maybe, a tiny bit more matter than antimatter was created in the beginning. Over billions of years, most of the matter and antimatter annihilated each other. We are the leftovers. But even though antimatter is rare, its existence has profound implications. When matter and antimatter meet, they don't just shake hands and go their separate ways. They annihilate each other in a burst of pure energy. E equals mc squared, Einstein's famous equation, tells us exactly how much energy is released, and it's a lot. The annihilation of antimatter is the most efficient energy conversion process we know. A single gram of antimatter could produce an explosion more powerful than the atomic bomb dropped on Hiroshima. It's enough to make your hair stand on end, if you had any left after the explosion. This mind-blowing power has captured the imagination of both scientists and science fiction writers, but harnessing it is a challenge of epic proportions. Chapter 4: The Hunt for Antimatter. From CERN to the Cosmos. Researchers at places like CERN, the European Organization for Nuclear Research, are working hard to study antimatter. They use gigantic particle accelerators like the Large Hadron Collider to smash atoms together at nearly the speed of light. These collisions can create small amounts of antimatter, which researchers can then capture and study. But it's not just about ground-based experiments. Scientists are also searching for antimatter in space, looking for clues to its origin and properties. Chapter 5: The Future of Antimatter, Promise and Peril. Antimatter is already used in medical imaging, such as PET scans, which use positrons to create detailed images of the body. And while antimatter power plants may still be science fiction, the potential benefits of harnessing this ultimate energy source are undeniable. But with great power comes great responsibility. The challenges of producing, storing, and safely using antimatter are enormous. It is a double-edged sword, a technology with the potential to solve some of humanity's greatest challenges or pose an existential threat. The future of antimatter is still being written, but one thing is certain: this strange and wonderful substance will continue to fascinate and inspire us for generations to come.